Hey everybody. Alright, today we are going to review how to solve one-step equations. Make sure you write down everything you see on the screen that is not already in your notes. Your objective: I will be able to isolate a variable to solve one-step equations. So let's talk about the difference between an expression and an equation. So an expression is just a combination of numbers, variables, and symbols that shows the value of something. So an expression would be something like, let me change that color, something like 10 divided by 5. Okay, we know we have something there and we're going to have to solve it to find out what the value is. Now an equation shows that the value of two expressions are equal. So a big hint that you know something is an equation is that it has an equal sign. So something like 2 plus 3 equals 5, that's an equation. It's showing that the left side is equal to the right side. Or something like x plus 4 equals 7. We know that the left side equals 7 and the right side equals 7. Alright, let's talk about the parts of a one-step equation. So the first thing you really want to remember is that the letter is your variable, and that's just representing an unknown number, and this is the big thing that we're solving for. We want to find out what this letter actually means. Now a constant, that is just a number or variable on its own, so this 5 right here would be the constant. And then all the parts of an equation are called terms. So a variable is a type of term, and a constant is a type of term. Alright, whenever we solve one-step equation, we have to use inverse operations. And inverse just means basically that it's like the opposite operation. So if we have an addition problem, we would want to subtract to find the value of the variable. If it's a subtraction problem, we would add. If it is a multiplication problem, we will divide. And if it's a division problem, we will multiply. Alright, so let's talk about our steps. The first thing we want to do is separate the left and right side of the equation, and you'll see what I mean by that in a moment. Then we're going to use an inverse operation to quote-unquote move the constant. Then we're going to solve and rewrite. We're going to check our answer, and we're going to graph. So let me show you what I mean with all these steps in some examples. Alright, example 1, x plus 2 equals 5. So something plus 2 equals 5. So what I'm going to do is I'm going to separate the left and the right side of the equation. And I'm going to bring down my equal sign. So here's our left side, here is the right side. So if the right side equals 5, I know that the left side also has to equal 5. So I need to figure out what can be added to 2 to give us 5. So since this is an addition problem, I know that I have to do 5 minus 2 to solve for the missing value. So I'm going to subtract 2. 5 minus 2 is 3. Now, since I have taken care of this 2, I've basically moved it to the other side, I'm going to write minus 2 over here as well. That's just letting me know that I've taken care of this, I've subtracted it from 5, now I'm done with it. And I'm just going to carry down that x value. So that means x equals 3. Now I'm going to check. So I'm going to take this 3 and plug it in for x. So that means 3 plus 2 should equal 5. We know 3 plus 2 is 5. The left and the right side equal each other, so we know that our answer is good. Now we're going to graph the answer. So I'm going to label this, I'm going to have a 0 here, and I'm going to label it by 2's. And you can label this however you want, just as long as you have a positive 3 located on there. So a positive 3 would be located here, and I'm just going to put a dot. And that is showing that on that graph x equals 3, and that's it. Alright, let's look at example 2. X minus 8 equals 10. So something minus 8 is going to be 10, so I'm going to separate the left and the right side of the equation, and I'm going to carry my equal sign down. Now, since this is subtraction, I want to add. So I want to know what is 10 plus 8, and that should give us the value of x. So let's add 8. 10 plus 8 is 18. Now since I've added 8, I'm going to rewrite that here, and I'm just going to cross that out. I've taken care of that, and I'm left with that x value. So x equals 18. Now we're going to check. So if 18 is x, then 18 minus 8 should equal 10. 18 minus 8 is 10. The left and the right sides are equal, so we know that this checks out. Now we're going to graph. So our value is 18, so I'm just going to make sure that I have 18 on the graph. And I'm going to go by 2's just because this is a little close together. Again, you can label this with whatever numbers you want as long as you're going from least to greatest and you have your answer on your number line. So if x equals 18, I'm just going to put a dot right here, and that shows us that x equals 18. All right, example 3, we have x times 3 equals 12. Remember, whenever we see a number in parentheses right next to another number, that means we're multiplying. And you could also see this written as 3x. That also means multiplication. So I'm going to separate the left and the right side and carry down the equal sign. So something times 3 equals 12. So I want to do the inverse of multiplying, and I want to divide. So I'm going to do 12 divided by 3, and we know that's 4. So since I've divided by 3, I'm going to write dividing by 3 over here and cross that out. And I'm left with x. Now 3 divided by 3 is 1, so that means I'd be left with 1x. I don't have to put the 1 in front of it because 1x is literally just x, which is what we have written here. So x equals 4. Now I want to check and make sure that's correct. So that means that 4 times 3 should equal 12. 4 times 3 is 12. So the left and the right sides match, and that does check out. Now let's graph it. So I know my answer is 4, so I'm going to make sure I have 4 on my number line. And then I'm just going to put a filled in dot on 4. All right, example 4, we have x divided by 5 equals 7. So I'm going to carry down the equal sign. Now if we are dividing by 5, we want to do the inverse of that to find the answer. So I want to know what is 7 times 5. So I'm going to multiply by 5, and 7 times 5 is 35. Now on this side, I'm also going to go ahead and write multiplying by 5. If you divide something by 5 and then multiply it by 5, you end up in the same spot. So that basically cancels out, and we're just left with x. So x should equal 35. Now I'm going to check. So if x is 35, then 35 divided by 5 should equal 7. 35 divided by 5 is 7. The left and right side are equal, so that checks out. And now we are going to graph it. So my answer is 35, so I'm going to put a 35 here, and I'll just go by 2's. And then I'm going to put a filled in dot at 35, and that shows that x equals 35. All right, let's do one more example together. Sometimes you might see a division problem, but x is on the bottom. So let's talk about what to do here. So this problem says that 27 divided by x equals 3. So I'm going to bring down the equal sign, separate the left and right sides. This is a division problem, and we said that the inverse of division is multiplication. Now, we multiply these values together right here. So I'm going to go back. On example 4, we multiplied 7 times 5. So we multiplied that number that was alone, we multiplied that by what was on the bottom. So we're going to do the same thing here. We're going to multiply 3 times x. And 3 times x, I mean, we don't know what that is, so we're just going to write it as 3x. Then over here I'm going to multiply by x. If I divide and then multiply by the same number, they cancel out, and I'm left with 27. So 27 equals 3x. Now I still have a one-step equation, and I still have to solve that. So now I have a multiplication problem. So 3 times something equals 27. So I want to isolate this x, which means I want it to be alone. I've got to get rid of this 3. So if we are multiplying by 3, the inverse would be to divide by 3. 27 divided by 3 is 9. 3 divided by 3 is 1, so we're literally left with 1x. And if you want to rewrite that with x on the left, you can. So x equals 9. Now let's check. So that means that 27 divided by 9 should equal 3. 27 divided by 9 is 3. The left and right sides are equal, and that checks out. And now I'm going to graph that. So I'm going to put 9 here, and then I'm just going to label in 2's. And if x equals 9, there will be a filled circle at 9. Alright, now it is time for you to try the following 2 problems. Make sure you show all of your work and bring your notes with you to our next class. And we will see you next class day.